entrepreneurship centers at the Hebrew University, at Tzuriel, and at Bezalel. So we're very excited to see what we have here today, and I wish you all best of luck. Thank you very much.
Thank you, Noam. And I also want to take this opportunity to thank our partners of this event from Startup Nation Central and the Israel Innovation Authority. Thank you so much for taking part of the lab. So let's talk about the prize that the winner of this lab will receive. So the winner will receive 3 different prizes. First, they will compete with their projects at the annual Global Falling Walls competition in Berlin in November. The winner will also receive professional guidance from JLM Impact, as well as a professional pitch video showcasing their project, which will be shared on all of Global Falling Walls' digital platforms that will receive a lot of exposure. So the winner will receive these 3 wonderful prizes. These are the winners from the past 2 years. And last year, the winner, Amit Rimon, who won for breaking the wall of antibiotic-resistant infections, also placed in the top 10 in his category at the competition. So there are big shoes to fill. And of course, we can't have a competition without a wonderful jury. So I'm excited to announce and present to you all the jury that have joined us today. So we have Professor Shlomo Magdassi, Professor of Chemistry and the Chairman of ASPER-HUJI Innovates at the Hebrew University of Jerusalem. We have Tammy Berenstein, Head of the Screen-Based Arts Department at Bezalel Academy of Art and Design. We have Professor Heitam Kassem, Head of the Department of Mechanical Engineering at Tzuriel College of Engineering, Jerusalem. We have with us Wendy Singer, Executive Director of Startup Nation Central, Zaki Jamal, Founder and Managing Partner of Fresh Fund, and Stav Erez, partners of Labs O2. So thank you all to the jury for being with us today. So let's begin. So what do we have with us now? We have 9 pitches from the 9 finalists. Each pitch is 3 minutes each. You guys can all see, all finalists, you could see Falling Walls countdown. And here on that screen, you will have a countdown of 3 minutes, and it will start turning red from 30 seconds and below. I will give a quick 10-second notice, and then at 3 minutes, we need to stop. And then we will have 2 minutes of questions from the jury. And then before we move on to our next presentation, each of the finalists, you guys will be able to share your screen. I ask that you only share your screen during your presentation and stop sharing during the question answers. We will then break off for jury deliberation for half an hour, and then we will have the award ceremony. So please keep in mind to stay muted when you're not speaking, to make sure that it's quiet and we give the respect and attention to the finalist that is presenting. And yalla, I think we can begin. So happy to announce the first finalist that will be presenting, Dana Poutsy, Breaking the Wall of Water Treatment. As Dana, the floor is yours. Feel free to share your screen. And Meule, and the countdown will begin as soon as your presentation is on the screen.
Okay. Hey everyone, my name is Dana. I would like to share with you our novel water treatment device for rural areas. Okay, let's start. How obvious it is to open our tap and magically get a clean stream of fresh water with no concern of how it can affect our lives. That is not the reality for a big part of the world. Over 100 million families in India alone do not have the simple tap at home. They collect the water from contaminated lakes or unmaintained community sources, resulting in countless health issues and high mortality rate. The common solution are boiling, chlorine, and filtration systems. They are unscalable due to the cost. They demand heavy maintenance, and they depend on supply availability. And most importantly, this solution has limited effect against viruses, which are the main and significant factor for mortality and illness, especially in COVID era. This is why we developed SOLID using our multispectral technology. SOLID is a small and portable device. It's powered by the sun, by solar energy, and based on our patented lab technology. The device can be connected to any standard pipe or filtration system, as you can see here in the illustration, and the flow rate is between 1 liter per minute to 4 liter per minute. Once the water streams through the device, it's immediately purified by the UV light. It's eliminating any kind of virus or bacteria. In the past 5 years, we developed the LED-based method that formulates an optimal combination of UV wavelengths to overcome the LED drawbacks for rural areas, costs, energy consumption, and organism recovery in water storage tank, while dramatically reducing the biofouling and maintenance. This optimization can be done thanks to our all microbiology know-how with years of experiments and models, with deeply understanding the microorganism direct and indirect damage mechanism. Thank you very much. Any questions?
Thank you, and opening the floor to questions from the judges.
Yeah, I have a question. The idea of using UV light to disinfect water is quite known, and there's many companies already producing such instruments. So what's the novelty in your approach?
So actually, in our approach, we find the optimal combination of UV LED wavelengths, like with all the, we optimize all the characterism of the wavelength, and then we can achieve a synergy with the inactivation. Like if we will use one wavelength, UVC wavelength, we achieve a low inactivation in compared to combine two wavelengths together with our optimal combination.
So you're having two wavelengths?
Two and more, with slight, we have, it's two and more, but it's not just to combine the wavelength. We need to get an optimal combination, like with all the LED properties, because LED has each LED has a different photon scattering and different electrical output power. So we just need, we find the optimal combination that will yield a higher inactivation in compared to one wavelength.
Thank you.
I have a small question, if it is possible. What is the duration time that you should expose the water to this UV?
Generally, it depends on the wavelength, but we should expose it like a couple of minutes. A couple of seconds.
Couple of seconds. So in fact, the flow will depend on this time.
Yeah.
Okay.
Thank you very, very much, Dana.
Thank you.
So we're now going to give 30 seconds to a minute for the judges to put in their scores. And in the meantime, Dr. Heba Alkhatib, you can get your screen prepared for your presentation. Okay, So I am pleased to introduce Dr. Heba Alkhatib at Breaking the Wall of Cancer Drug Resistance. So we will begin the countdown now.
Okay, hi. Over a year ago, I lost my best friend, my father, who worked as a UN medical officer in Gaza Strip. Ever since he developed resistance to cancer treatments, the only thing I was able to think about was that this wall of cancer must fall. A tissue and organism can be compared to a government in real life. Once the tissue or the government is in homeostasis or steady state, we have a peace. But we might have a government that causes the deviations from the steady state. So how do we replace this corrupted government? In cancer, we have exactly the same kind of question. How can we find an approach that allows us to identify and target central players responsible for the deviations and preventing the tissue from reaching homeostasis? Let's say we have two patients with exactly the same type of cancer. We go ahead and try the common clinical treatments, but one responds, the other doesn't. Why? So we switch to today's solution, which is personalized medicine based on biomarkers, but again, one responds and the other develop resistance. Why? So the answer is simply because those tumors are heterogeneous in nature, even though we refer to them with the same name. Plus, we are missing some additional central players responsible for the deviations and preventing the tissue from reaching homeostasis. So to solve this problem, we suggest to use a novel approach in medicine based on laws from chemistry and physics that allow us to identify altered patient-specific protein-to-protein networks, and also to suggest the central players inside those networks, preventing the tissue from reaching homeostasis or steady state. So now, based on these networks, we are able to predict patient-specific barcodes, which enable us to predict and suggest the patient-specific drug combination, which is going to be targeting those central players. And here is one of many examples on how our predicted therapy worked in comparison to other clinical treatments, not only in reducing the size of the tumor, but also to prevent its regrowth. And this validation has been done in many types of cancers already, including melanoma, lung, breast, and oral cancer. And before I drop this, it's worth mentioning that we recently opened a company and we're headed to clinical trials soon. Thank you.
Thank you very, very much. And now we have time for some questions.
Is this relevant for all kinds of treatments, like biological treatments, chemotherapy, or like a specific treatment?
Yes, so the drugs that we use are FDA-approved drugs, inhibitors. But the novelty in this is that we are able to predict exactly patient-specific alternations, and based on these alternations, now we go and target those alternations with inhibitors, not chemotherapy, not radiotherapy. Those are already like FDA-approved drugs, so they're safe. They're totally like not toxic drugs, and in this way, we can actually break down the alternation that is causing the tissue to deviate from the steady state.
Is there anything like this?
Cancer is a big word, and I didn't understand what are you going to do with your unique approach. Treating drug resistance is quite known. So what is your specific breakthrough that you want to convey?
So what I'm saying is that our novelty is we are able to predict patient-specific drug combination. So we take the patient, like we take a biopsy or like the tumor inside this patient, and we analyze it based on this approach. So we are able to identify the steady state and the deviations from the steady state. And this deviation is actually a small perturbation inside the tumor, inside the whole tumor. So based on this perturbation, we are now able to say, okay, so this protein is going up, and this protein is like correlate with the other protein. And if we break down this whole network by targeting the central protein responsible for making this alternation, we can now break the whole tissue, like the whole system of the cancer.
Thanks.
Zaki, did you have a question? No.
It was the same question, just not as eloquently.
Okay, wonderful. So thank you very much, Heba. We will give time now for the judges to put in their scores before we move on to the next presentation. In the meantime, Saar, would you like to put your presentation up and get ready? Wonderful.
You may want to just put your presentation in presentation mode. Yeah.
Perfect. So let's just give a couple more seconds for the judges to input their scores. Okay, so I'm happy to introduce our next finalist, Saar Nehemia, who will be presenting on breaking the wall of nanochip fabrication resolution limit. So good luck, Saar, and the countdown will begin.
Thank you. So, hey everyone, my name is Saar Nehemia, and I'm a master's student in physics at Technion. Today, I want to tell you how my research can have enormous impact on the electronic chip industry. But before we begin, let me give you a simple analogy that I hope will make things clearer. Imagine playing hide and seek in a big city like Berlin with a tiny ant, and we have to find her as fast as possible. This is our challenge for today. Keep this in your mind, and now let's begin. The electronic chip industry, The electronic chip industry is one of the biggest industries around the globe, with sales reaching more than $400 billion. Many of you probably heard about the electronic chip shortage. The supply simply struggled to keep up with the huge demand. Joe Biden states recently that he plans to invest $50 billion to support it. Now think about it for a second. Electronic chips are everywhere, in our coffee machine, car, and of course in our beloved smartphone. A single electronic chip is only several millimeters in size, and that's how it looks from the inside. Just kidding, that's a satellite photo of Berlin. This is a modern electronic chip photo. See the similarity? Those chips are super crowded with tiny transistors, and every year they are just getting more and more crowded. Now, what happens if there is a defect in one of those transistors? How can we find it among 50 other billion transistors all crowded in a millimeter-sized electronic chip? Remember our analogy? Now that's the ant we are trying to find in Berlin. To solve it, we need to see deep into the material and with very high resolution. Apparently, there is no easy answer for that. And a lot of companies try to offer the best solution. Today, most of the data is collected using two main tools, optical microscopy and electron microscopy. Optical microscopy uses light for imaging, and it gives us the ability to see deeper layers of the material, but with limited resolution. Electron microscopy, on the other end, uses electrons, which gives us amazing resolution, but because of scattering, it's pretty hard to see the deeper layers. So still, no solution for our problem. We propose a new and novel technique that combines both electrons and light, so we can have amazing resolution while still reaching the deeper layers of the material. Our setup combines an electron microscope with an intense laser beam that is guided into the microscope. The electrons act like our eyes, and the light is a flashlight. Using the light, we can highlight the defect on our chip very easily, so the incoming electron can see it very clearly. And that's it. We found our defect and possibly save millions of dollars. Only few laboratories in the world have this tool, and luckily, we are one of them. In our research group, we have experts both on the theory side and the experimental one. The set of skills needed to understand the interaction itself and how to operate this instrument are very unique, as they include deep understanding in physics, optics, and electron microscopy. Thank you very much for your attention, and I invite you to invest in our project, and together we can help develop the chip industry of the future. And with that, I'll take questions. Thank you.
Perfect timing. And the floor is open to the judges for questions.
So I will ask. I didn't really get the basic idea. So you're going to combine the electron microscopy with optical microscopy. How?
Okay, so in our lab, we have something called, the machine is called UTEM, which is the ultra-fast transmission electron microscopy. And we combine the electron beam that comes down the column of our microscope with an intense laser beam that is coming from the side. And both of them hit the target. And then the light can highlight defect because of the non-uniform of the defect, because it's very spatial in the chip. And then the electrons will be scattered from it, and we can detect them very easily. That's the whole idea. That's what we do in our lab usually in our experiments.
Okay, thanks.
You're welcome.
What is the background of the people who are working on this project?
The background needed?
What is your background, your partner's background?
So my background, I did my bachelor degree in physics and mathematics. And in a group, we have a material scientist, we have electrical engineering, mechanical engineering, and also physicists, of course. And we need to study electron microscopy, which is a very powerful tool that most of the, not most of, but a lot of a research group using it because it have very high resolution. This is the nanometer resolution, or even better sometimes.
Do we have any other questions from the judges?
Yeah, can you maybe help illustrate the impact with maybe a use case or two, or an example of how this can really affect lots of people? I mean, I know there's obviously lots, but I'm curious as to what you'd prioritize and share.
So from what I know, the electronic chip industry now have a very severe challenge because everybody wants chips, especially in the COVID time, where anyone just buy another TV or another computer. And the supply they don't make it fast enough and with large quantities. So, and every time, like the fabrication process, you need to invest, it's a very complex process that includes the fabrication, and after it, you need to inspect for defects. So if you find even a tiny defect, you have to throw it away. Because imagine you put it in a medicine machine and it stopped working, and someone stopped to get his oxygen or something like that. So, and if you throw it away, you lose money. And all of these companies want money. So our idea is to find those defects with higher efficiency and also hopefully faster. So it will save money and also hopefully save life.
Thank you very much, Saar. We need to now give time for the judges to evaluate. And in the meantime, Ziv, you can put your presentation on the screen. We're just waiting for the last scores to be inputted, and then we will begin in a minute. 1 second. Okay, so I am excited to announce our next finalist, Ziv Avraham, who will be presenting on breaking the wall of world plastic waste. So Ziv, go ahead.
Thank you very much. Hello, everyone. 8 days ago, the UN's Committee for Climate Change declared Code Red for humanity. Global warming is here. Within this crisis, 2 damaging processes continue to happen simultaneously. The first is plastic contamination. Every year, about 500 million tons of new plastic is produced worldwide. The amount of plastic waste is already simply unmeasurable. The second is the over-extraction of natural resources. Only in Israel, over 60 million tons of natural aggregates are extracted every year as raw materials for the construction industry. Clearly, our future is at risk. We are witnessing irreversible pollution and massive ecosystem damage. What if I told you that this problem can actually be the core of solution? Allow me to present ESC technology, which we founded to recycle plastic waste into non-constructive concrete products. Our patented technology is the first and only technology that can combine up to 70% of any kind of recycled plastic waste in concrete mixtures. That means that when used, it can completely eliminate plastic waste pollution. While doing so, we also reduce the use of natural resources that are extracted in quarries as building materials by approximately 30%. My name is Ziv Avraham. I'm an architect and I design buildings. As a founder of ESC, I'm working with a team of experts in the concrete business to bring innovation to this traditional field. Today, our tests show that our new line of concrete products is even better than the industry standard. Our team of researchers is currently working on optimizing the recycling process to make it cheaper. Here is an example. A standard 4-room apartment contains about 10 cubic meters of concrete that is made of about 20 tons of natural aggregates. The same apartment, built with ESC concrete, will use only about 1/10 of natural aggregates and 4 tons of recycled plastic waste. Our startup is already generating a lot of interests. We already received government funding by the Innovation Authority and have partnered with leading global players in the field. This competition is all about falling walls for disruptive innovation. Our technology will literally build the walls for our planet's sustainability. Thank you for this opportunity to present.
Thank you very much. And we would like to open it up to the jury for questions.
I have two small questions. The first is, recycling plastic is not really new. What is the novelty in your work? And second thing, what about the resistance and mechanical properties of this material when you use this in construction, for example? Thank you.
So first of all, I said that our product is for non-constructive concrete products. So it works with all the regulatories and all the need for this kind of products. And the second question about the competition, now our main competitors are the plastic bricks. And this kind of industry requires too many industry adjustments, while our technology use the existing technology, the tools, the knowledge, etc.
So what is the technology?
The technology is how to combine plastic instead of natural aggregates inside concrete. This is the patent.
I have a question, sort of continuing from Professor Qasim's line. Can you say anything about the competition in this space? And is this company, this Israeli company called UBQ, doing something similar? It felt to me somewhat similar, but maybe not.
So it's not similar. I didn't say that in the presentation, but more than 90% of the plastic waste goes to landfills. We are looking for this kind of waste. Some of the plastic waste is going to recycle to existing industries. We are trying to manage or to use the existing, the plastic waste that nowadays goes to landfills, over 90% around the world. So U-Cubic use different kind of recycling, use recycling for industries. This kind of plastics costs much more money, and they can use only small part of the total waste plastic.
Okay.
Okay, thank you very much, Ziv. So we will give time now for the judges to score. And in the meantime, Te'era, you can put your presentation on the screen. Okay, Pera, are you ready?
Here I am.
Okay, so I am happy to introduce our next finalist, Pera Wasserzug Pash, Breaking the Wall of Women Reproductive Aging. So, good luck.
Okay. Hi, my name is Pera, and today I will break the walls of women reproductive aging. In the last decades, the lifespan and life quality of humans are in consistent increase. At the same time, and perhaps as a result, the age in which people are raising a family and having kids is delayed. And there is our problem, because the woman reproductive system ages fast, limiting the reproductive lifespan to a young age. So practically, while the total lifespan is increasing, the delay in childbirth is leaving the woman with shortening reproductive lifespan. And that is the problem we want to solve. The time window women have to conceive is extremely narrow, and occurs when the biological settings are already suboptimal. How could we change it? We study retrotransposons. Retrotransposons are particles inside our cells that act like viruses. Mostly, their expression is tightly silenced because their activity can cause major damage to the cell. In our study, we observed an elevation in this harmful viral activity in the aged female gamete, in the aged oocyte, and we proved that this elevation was causing the loss of functionality and quality in those cells. Using antiviral agent on aged oocytes, we inhibited this activity, and that resulted in oocyte recovery. The treated oocyte presented lower cellular damage and higher functionality. And that brings us to our solution. We suggest to administer antiviral drugs as a treatment for age-related fertility loss. The drugs will target the harmful activity of these hazardous particles in the oocyte, will inhibit their activity, and will improve the oocyte functionality and quality. And that will expand the woman's reproductive lifespan. In this way, women will have wider window of opportunity to have kids with better fertility potential. The solution is optimal because it targets viral pathway that harm the oocyte natural development. In this way, with careful design, we could only interfere with the viral activity and not with normal human tissue and cells equilibrium. Thank you.
Thank you very, very much. Open to the judges.
Yeah.
Could you describe, please, the downside or the risk with this procedure?
As any applied medicine, we could have systemic effect on the body and on other tissues, but there are available antiviral drugs that are used and approved, and even approved for pregnant women to use. And I do believe that we can narrow down the risks and actually focus on the specific activity of the viruses. And I actually don't see any further risk than normal use of antiviral drugs.
Do you have any proof of concept?
We have now in peer review, we have now an article that showed this work in mice oocytes.
So you're claiming that the reproducibility problem is caused by viral issues?
By viral issues that originate from the cell, yeah.
Thanks.
Do we have any other questions?
Maybe you could say, if Pera, is there anything similar being done in this space? How unique is this treatment?
So far, there are two clinical settings for treating age-related fertility loss, giving birth early, or freezing oocyte while you are young. Later, it's a problem. There is no solution. Like people can go to assisted reproductive technology and to doctors, but eventually, at some time point, there is no way to conceive in the mid-40s to mid-40s, and even in the late 30s, it can be a major problem.
Okay. Oh, do we have another question? No. Okay. Thank you so much, Pe'era. And we will give time for the judges to put in their scores. And in the meantime, Daniel, you can put your presentation on the screen. We're just waiting for the last couple of points to be put in, and then we'll begin. Okay, I am pleased to introduce our next finalist, Daniel Hizkiyahu, Breaking the Wall of Relationship Discontinuity in Healthcare Technologies.
Hi, everybody. I'm Daniel. I'm a nurse at Hadassah Hospital, and my research is on relationship discontinuity in care. I'd like to tell you about the surge in data-driven tech solutions in healthcare. They are based on databases that are collected from clinical data, management data, and information like gender, age, place of birth, and occupation. A massive problem in healthcare today is the patient's engagement and adherence to treatment. The outcomes depend on those factors, and as much as advanced the technology might be, when it is delivered in the wrong way to the patient, the outcomes will be not as predicted. Today, data is collected in a biased way, in a way that neglects relationships established between patients and their caregivers. The formal introduction, the knowing of a patient's beliefs and life consequences are missing from databases. And the solution that I found in my research is that there are pieces of data that can be mined from the excess data that is left today in healthcare. When making an intake at the hospital, the patient gives his information about his illness. I found that almost 95% of the information given is missing from the intake. So medical documentation is missing from the relationships. The missing access data, it withholds within itself those persons' beliefs, his past experiences, his introduction to the system. When we collect this data, when we mine it, and we enrich our machine learning methods for those tech solutions, we create a healthcare technology that is based on relationships. While if we will give those machine learning protocols touch of a nurse or a physician's empathic intelligence while doing segmentation and classification, we might get a better AI or a better algorithm that collects and introduces relationships in its solutions. Thank you.
Thank you very much. Are there any questions from the judges?
There's quite a lot of companies that I at least mapped that are trying to validate this process and I don't know, better have a better transfer the data better. I'm trying to understand your innovation.
Let's take a company like K-Health that is trying to bring the personal and personalized treatment and care. In this case, they again use information like gender and place of origin to map maybe temperature from where a person came or pollution from where a person came to assess maybe his, again, medical or health risks. But the relationships, they lie in the front lines, in the communication. When you bring a new technology that cuts straight to the solution, you miss on that phase, and the outcome might be of a lesser, the outcomes will be less and less successful.
Do you have proof of concept of this model?
I have a workshop with face-to-face workshop with the nurses, where we discuss the information that is missing from clinical documentations from the HMOs, and there I see a good success with getting the reaction from nurses and the motivation to use and collect this information to try and pass it from a shift to shift in a hospital situation, for example.
And did you try, for example, to quantify the relevance and the credibility of the information that you can get with this model, for example?
From the research I've been reading and the solutions offered, there's a big emphasis on patient experience and its cause for a better outcome in care. So patient experience has a big reliance on the relationships, on the how the information was given to the patient. So I'm relying on those researchers.
Thank you very much, Daniel. We need to move on to the next finalist.
Thank you.
So let's give time for the judges to put in their scores. And in the meantime, Geffen, you can put your presentation on the screen. Okay, so I'm happy to introduce our next finalist, Geffen Yamin, Breaking the Wall of Sustainable Air Filtration. Good luck, Geffen.
Thank you very much. So most of us lives in cities, in an environment that is full of air pollution. In fact, according to the World Health Organization, there is 4.3 million deaths every year from air pollution. But what do we do to protect ourselves from death? We close our doors, we close our windows, and we hope to keep this pollution outside. But you know what? We fail miserably. The truth is that we have trapped this pollution inside, which makes indoor air 5 times more polluted than outside. That's important because 90% of the people spend 90% of their time indoors, and that's during our regular years. So indoor air quality is critical to our health. And to deal with that, we buy synthetic air filters. And actually, during 2019 alone, 50 million air filters were purchased worldwide. Then, every half year, we need to replace the filter, which eventually condemned to the landfill, since air filters cannot be recycled and making the overall pollution even worse. Thus, my creation process was led by the belief that everyone deserves having access to fresh air without compromising our environment. And so I asked myself, instead of shutting nature out, how can we embrace its self-cleansing properties? And that's when I first heard about microalgae, a microscopic algae that produces 70% of our oxygen on Earth. Not only its oxygen production is 20 times or more than that of a generic houseplant, it also uses nitrogen dioxide and sulfur dioxide components, which are highly toxic pollutants endemic to our homes, as its nutrients. So that means that letting algae clean the air is basically feeding it. So the solution I'm suggesting is an air purifier based on a microalgae filter for our homes. And this is how it works. We start with a container filled with water, microalgae, and nutrients. The polluted air is pumped through the algae, which removes the polluted particles, reduces the carbon dioxide, and produces fresh oxygen. Also, the algae communicate with us by changing its color. For example, after 2 months, it will become darker, so it will show us its need to be diluted. And a great thing about the algae is it can be recycled as a homemade fertilizer or dispose it harmlessly. My system provides an ecological, sustainable, and economical alternative to the generic air filters and an experience of a codependence with nature, which the system serves us as a symbiotic partner, provide us with a clean air in exchange to our care. Thank you very much.
Thank you very much, Geffen. And now questions from the judges.
What about the energy consumption for this product? And another question is about the material of the dust. Is it something universal for whatever is the material, or just adapted for a kind of material?
So it doesn't require a lot of energy. Actually, it uses 12 volt for all of the product. And can you explain again the question about the material, please?
This is to the dust inside the houses is material, something you talked about oxygen and about carbon dioxide, but if you have something else, for example, does it work or not?
My filter is a microalgae. It's a biological thing, and it doesn't have another filter. So the algae does all the purifying. It reduces the carbon dioxide. It making the photosynthesis and produce us with the fresh oxygen.
But isn't it the same as every plant is doing at home?
So yes, it's like a plant, but on steroids. It makes a photosynthesis 20 times more than our house plants, and also removes our polluted particles and nitrogen dioxide and sulfur dioxide, which plants don't deal with.
And has anyone else suggested this idea before?
Yes. So there were projects using microalgae technology to purify air. but most of them were trying to purify our outdoor air. So putting microalgae besides roads and highways, which are very polluted. In Switzerland and Mexico, it's standing. But I want to take this technology and put it inside our homes because the indoor air is 5 times more polluted. And I really believe with the symbiotics with nature and us being involved in this process.
Thank you so much. Oh, sorry, did you have a follow-up? Okay, thank you so much, Geffen. And we need to move to our next finalist. So we'll give a moment for the judges. And in the meantime, Tzuriel, you can put your presentation on screen.
Did you see my screen?
Yes, we could see. We're just waiting for the last scores to be put in. So one moment. Okay, so I'm happy to introduce our second last finalist, Tzuriel Metzger, breaking the wall of chiral synthesis utilizing electron spin. So good luck.
Hi, my name is Tzuriel from the Quantum Nano Engineering Lab. Life is chiral. This means that from not entirely known reasons, organisms usually prefer a specific symmetry. For example, Homo sapiens absolutely prefer right helix of proteins and DNA. The artificial sweetener aspartame is sweet only in a certain direction. Its mirror image is bitter. This fact is true in many fields, including food, agriculture, and medicine. While a given molecule has a therapeutic activity, its mirror image may be unresponsive to the body or even toxic. In exactly such a case, in the 60s, humanity paid a very heavy price. Thalidomide was given as a drug against morning sickness in pregnant women, but only the right component is active, while the left one caused tragic malformations in newborn. If so, the importance to obtaining chiral pure materials is obvious, but such a task is difficult due to all physical and chemical properties of chiral pair being identical. All existing chemical methods to chiral separate or synthesis or chiral synthesis involve additional chiral component and are therefore very specific, very expensive, and not always trivial. I want to emphasize again an important point here. To obtain a chiral pure product, a chiral reagent is required, making the solution very specific. Specificity means complexity, as well as high cost. Our proposed solution is a generic, simple, and cheap system for chiral synthesis. The solution we offer, a symmetric system, except the magnetization of the substrate. Its role is to catalyze the reaction, meaning to carry out it more efficiently while directing it via the magnetized surface. The absence of chiral reactant in the system allows it being generic. Any reaction that may be catalyzed on a magnetized surface can be directed by this effect. Our system was proven for 3 different reactions from 2 families. My take-home message is, as we can see here, that chiral product can be obtained from a chiral reagent. The symmetry of chiral product can be directed by the surface magnetization. This fact is critical for crucial life-related inducers. Thank you.
Thank you very much, Tzuriel. And we now have time for questions. Do we have any questions? So thank you very much, Tzuriel. And
Thank
we'll
you.
give time for the jury to put in their scores. In the meantime, Noam, you could put your screen. Great. Okay, one moment. Okay. Okay, so I am pleased to introduce the last finalist of the day. Thank you all for sticking around. Noam Steinman, Breaking the Wall of Repurposing Old Drugs. Good luck, Noam.
Hi, everyone. My name is Noam Steinman from the Hebrew University of Jerusalem, and I'm going to present to you Breaking the Wall of Repurposing Old Drugs. What you see here is a number of familiar drugs, paracetamol, morphine, L-Dopa, etc. These drugs are very well known and very commonly used. What's common between them is a functional group called phenol. This functional group is a critical part of the functionality of each drug in its own way. And we will use it as an opportunity to modify these drugs. Why do we want to modify these drugs? Well, first of all, they're old, okay? And so their function and their use is known. There's no innovation that can be done because their structures are as they are, and we have no control over them. Sometimes they have undesirable properties. As an example, you can see morphine is addictive, or some drugs don't have proper bioavailability or can't be used in certain settings. Old drugs like CBD are new again, but the way that we can really properly assess and increase our control and modify the properties of these drugs is by transforming this phenol group into a salt with a metal. The transformation of these drugs into metal salts has many advantages. First of all, it's a novel class of compounds. And so from a IP perspective, it's very patentable. In fact, we've actually already have our first PCT application has already been submitted. The novel class of compounds can have very many different types of properties, from solubility, bioavailability, toxicity. Any drug or any really active compound that has a phenol group, which is many, can be modified in this way. An important part of this project is that from a regulatory perspective, the transformation from a phenol into the metal salt should not require new regulatory approval, as the salt can be reconstituted to the original phenol in a very simple process over time. This change of the drugs into metal salts is perhaps a minor modification, but it can bring new life and new perspectives to old drugs. Thank you for listening, and I'm happy to take any questions.
Thank you, Noam.
When you make this modification, isn't it a new drug, and then you have to go all over the regulations and testing?
The advice that we have gotten from our patent legal team is that this will not be necessary, as the the original phenol can be reconstituted easily, and therefore it's not considered a chemical, enough of a chemical change to require more regulatory approvals.
It's not a patent issue, it's a patent of regulation. So I'm afraid that it's not the right approach.
Do we have any other questions? Okay, so thank you, Noam, and thank you to all of the finalists for presenting. What is going to happen now is the judges will be moved to a breakout room. We will put a countdown clock here for 30 minutes, and the judges will deliberate, and we will come back with announcing who the winner is at 12. So thank you. Now's your time to make your cup of coffee, to take a breather, to all of that. So thank you very much. And judges, we will see you in the breakout room. Buddy, welcome back. We just finished deliberating with the judges. And before I announce the winners, I want to congratulate all of the finalists on your presentations today. Congratulations. They were all great, and it created lots of interesting dialogue within the jury deliberation. I also want to thank our partners of JLM Impact, Yoav Friedman and Eyal Fried from Bezalel, Michal Mizrahi and Ophir Kelty from Israeli, and of course from the ASPER-HUJI Innovate team, Amnon, Ayelet, Itai, Yotam. Thank you all very much. So without further ado, I would like to announce the three winners. So the first place winner will be flying to Berlin and will be receiving all these exciting prizes. However, I do want to say that JLM Impact is here for all of the finalists. If you want to consult with us or discuss or have any questions, we are here for you. So even if you didn't win, we would love to stay in touch and help out however that we can. So without further ado, I'd like to announce the third place winner, which is Saar Nehemia, breaking the wall of nanochip fabrication resolution limit. So congratulations, Saar. Okay, at second place, we have Ziv Avraham, breaking the wall of world plastic use. Congratulations, Ziv. And drum roll, you can't hear it, but drum roll, please, for the first place winner of the Falling Walls Lab Israel 2021. Our representative in Berlin in November is Dana Poutsy, breaking the wall of water treatment. So congratulations to all of you. Congratulations to the three winners. We look forward to seeing what you all will accomplish down the road, and we are here to help. And of course, thank you again to our jury. Congratulations. Hope you all.
Thank you very much.
Amazing. So we will be in touch with all of you, and we'll see how we can help out in the future. So bye. We hope you enjoyed.
Congratulations.
And thank you, Keshet, for organizing it so perfectly.
Yes, Keshet, flawless. Thank you.
Thank you. And good luck to all competitors. We hope to hear about your companies.
Definitely.
Thank you, Keshet. Bye-bye.
Thank you, everybody. Bye-bye.
Thank you. Bye-bye.
Bye-bye. Bye. Thank you.